Hello, everyone. Welcome to the next episode of AI Guide to the Galaxy. My name is Oleg. I work with Docker, and this is my utmost pleasure to welcome our next guest in the studio, the CEO and co-founder of Unsloth AI, Daniel. How are you doing today?
Yes, hello. Yes, nice being here, and thanks for inviting me. I'm super excited to be here.
Uh, right. So, Daniel, you have a little bit like you were a little bit of a Reddit hero when you messaged
Oh,
on local ammo, something like this. People are like, oh, that is Daniel from Unsloth. So I'm extremely honored to have you as a guest. And today we're going to talk about Unsloth. Obviously, I would love to touch on topics of fine tuning and running maybe smaller local models and get your take on the direction where this is going and how Unsloth fits in the ecosystem and what's your take on all that.
yeah,
So
sounds fun. More than happy to talk about like local models, reinforcement learning, training, and yeah, running on Docker as well. We have like new Docker images for you to run very easily as well. Yeah.
that's perfect. So maybe we'd start with a little bit of the general introduction to Unsloth. And so, how would you describe Unsloth? And I know that you also offer performance gains for both inference and fine tuning and reinforcement learning. So maybe you can introduce Unsloth and unveil a little bit of curtain. How do you get this massive performance gains, and what's the secret sauce behind that?
Yeah. So Unsloth is actually kind of like two disjoint components. We have like we upload quants for like large models, like Kimi K2, DeepSeek R1. We take like gigantic models and we quantize them to like 1 bit or like 2 bit. And you can also find them on Docker. You can do that like Docker run Unsloth and whatever the model that you like, or you can like get it from Hugging Face. So we do that side of things. So we do like chat template fixes. We work with all the large model labs like Mistral, DeepSeek, Quen. We work with them to like fix bugs in the models as well. So that's like one component. And then we have another component where we actually offer training. We make training and reinforcement learning much faster and much more memory efficient. So we have like two different components. They're actually, it's funny when we talk to like audiences, some of them don't even know that we have like a GitHub package for training. And some of the GitHub people don't know that we have like a quants thing. But actually they're very relevant to each other because like, if you want to train a model, you first need to fix the model first. And then you can train it and stuff like this. So we have like two different components. Yeah.
Awesome. Let's talk maybe about the reinforcement learning and inference engine. As you said, you offer memory uh,
Memory efficient, yes.
memory
Memory
efficiency and
efficiency.
performance gains. Like, is it because you're just better engineers? Do you run it on custom hardware? How is it? How is it working out?
Yeah, so our efficiency gains work on any single hardware. So, NVIDIA GPUs from the very oldest, like T4s, the RTX 20 series, all the way to the latest B200s. And also in AMD GPUs, Intel GPUs, it works across the entire board. The trick is we don't do hardware optimizations, we do mathematical tricks. So like for example, we offload gradients to like your system memory. So you don't actually use the GPU memory. And then the trick is if you do this wrong, it will be very slow, right? You're communicating with this CPU memory and then waiting for it to like load into the GPU memory. And so what we do is we kind of like do it asynchronously. So you hide the communication and the computation at the same time. So that's like one optimization. We do like many other optimizations. And then once you like add them all together, you get around 2 times faster to 3 times faster. And we also reduce memory usage using mathematical tricks as well.
Right? Does it work for? Is it like sort of the library optimization? So is it the kernels that you're writing, or do you need to update this for all upcoming new models? So
Yeah, good question. So previously we had, whenever a new model came, we would have to rewrite our engine for every single new model definition. So now we have this automatic compiler. So because like any single model that comes to us, we can automatically write kernels and it will just make it faster. Um, the process will be a little bit more slower. So like when you actually load up the model, it will take like, a few more minutes. But we have like an automatic engine now where it automatically writes kernels, automatically does like some maths tricks and stuff like this. Yeah.
that is fantastic. Well, I'm looking forward to trying to maybe fine-tuning something with Unsloth myself. This is something for me over the Christmas break, maybe. Can you maybe share some light on the second component that you had? So the GGUFs, the packaged models that you do, and I know there are different ways to quantize the model, right? And
Yeah.
for people who are not in this ecosystem yet, quantization is when you take the model weights and then they reduce the precision of those. So normally going from floating points, full long floating points, into maybe integers that are like 4 bits, right? So my first question, how does it work? How can a matrix reduce to integers from 0 to 16
Yeah, that's a
retain
great question.
any intelligence? Uh, but it's a rhetorical question, so I don't expect you to answer with math or anything. More importantly, so you have the quantization, right? Like like make the matrices smaller and more efficient to
Yeah.
multiply and stuff. But you also have the dynamic quants, right?
Yeah.
And my question is, why are Unsloth dynamic quants so much better? And how do they retain more intelligence in this kind of sort of zipped form, in this constrained form? And is it something that other teams and companies just don't want to do, or is there something like a reason behind why you are almost exclusively doing that and the rest of the world is pursuing some other direction?
Yeah. Let's break it down. So I think the first, like, what is quantization? I think so in a large language model, if there's like 1 trillion parameters, not all of those numbers are very different, right? It's going to be like 2.01, 2.02, right? There's going to be many of those like very similar numbers. And so the trick is we just make 2.01, 2.02, 2.03 just 2, right? We just like remove all the decimal points and we just make it 2. And so now you have like this way to like compress the model and delete all of these like decimal points, just get rid of them. And then you just have like these, small amount of numbers that you can represent. And so the funny thing is, this actually kind of works. It does not damage the model in any single way, right? If you like remove the decimal points, the model does reasonably well. But then if you do too much, like if you like try to compress it so much, for example, if you have like numbers 1, 2, 3, 4, what are you going to do? Like, you need to represent like 1, 2, 3, 4 as like one number. That is probably not a good idea. So if you just select 2 as the number you want to represent, you will essentially delete a lot of information. And so that is why you need to do dynamic quantization. So that's where the next thing comes in, where dynamic quantization allows you to select what is the correct numbers you want to represent and the scale that you want to represent it. For example, if it's 1, 2, 3, 4, you don't want to quantize this because it's too different. And so
Right.
the dynamic quantization methodology allows us to like select what is the correct form, how many numbers you want to quantize and stuff like this. In terms of other teams doing it, actually, I think it's actually quite popular now. I think so essentially in January of 2025, we introduced the 1.58-bit dynamic quantization of DeepSeek R1. That's kind of where it became somewhat popular, the dynamic, like, the name. And I think most people, most large labs, they just like do something similar to what we do. They would take a large model, they will quantize that down to like 4-bit or 8-bit. Yeah, so I think like most large labs actually do that now.
Okay.
Yeah.
Okay, that's perfect. That's awesome to know, and kudos for setting the direction for the ecosystem in there. Lovely, lovely. So maybe let's talk about the large labs and different models and the packaging that you do for them. Because for the local model consumption, people need, well, smaller or quantized models, because it's impossible to run like those giant beasts on local hardware, even if you have like a powerful NVIDIA GPU somewhere at home. Like, you're likely running DeepSeek like full precision uh, at home. So for normal people, right, you need to quantize things. And Unsloth is, of course, famous for packaging and going through all models from all the labs and uh, building those Unsloth dynamic quantization things to work. But you also are fixing like a lot of things in the models, and you were saying that um, that you are doing things. So a little bit maybe abstract question. What is the most common? What are the most common issues that you see in the high-profile model releases, and what are maybe the most fun or memorable that you have currently in memory? You don't have to blame and shame the models. You don't have to name
Yeah.
names, but if you can share some, what are those issues? That'd be great.
Yeah. So when we first released our models, like, the quantized models, we did not actually know that there were problems in the models until like when people started running them. They were like, okay, why is this not working? Why is the chat template incorrect? Why is like this, like, why is the output not right? And so after that, we then like spend some time, okay, like, oh, let's look at the model definition. Let's look, is the chat template correct and stuff like this. And so we noticed that actually, wait a second, nearly all large labs, it's not just like one person, it's like all of them have the same problem over and over again. They either get the chat template wrong, they get the wrong EOS, so they get the wrong end of sentence token. So the model will just keep going on forever. It will never terminate. They will get the wrong BOS token. They'll get like actual wrong architecture. Like, they chose the wrong epsilon. They chose like wrong numbers. They chose the wrong activation function. So these things actually are not. They're not just one. It's not like a isolated problem. It's like everyone seems to make the same mistakes over and over again. And so like what we do now is like we work with the large labs like, Google, OpenAI, DeepSeek, or, other labs, or Mistral, every single time before they release like a model, we will like inspect the model weights before they, give it out to people. And then we will tell them, oh, okay, there's like this problem or this problem or this problem. And then we will essentially behind the scenes now. So now it's more behind the scenes. We will release the corrected models
Right.
before their release date. Yeah. But I think
Right.
the most interesting one, hmm,
Well,
I
if
mean, they're
it's
all very interesting. Yes,
yeah,
they're
I
all
don't
very
want to put
interesting. Yes.
you on a spot like this. So here you said that the labs will give you the model information weights, right? So these issues in chat templates and choosing incorrect values, or these are not only obvious when you actually quantize the model, right? It is also present in the original like full precision model files. Uh, okay, that is interesting. So how now? Let me help you understand those teams that release the models, right? They are cream de la cream of, well, AI and computer science, right? They are extremely capable, bright AI researchers, engineers. Is it how is that
How is it
so many
possible for
models
them to
have
make
grown?
mistakes?
Yeah, no, but it's also like something like chat template, right? A
Yeah.
chat template is just is a schema for how you format messages to feed into an LLM, right? So to my normal engineer mind, this is the simplest part of the whole process. How is that? How is that? It is always broken. And
Yes.
another question, maybe a more general question, right? Do you think there could be some protocol standardization happening?
Mm.
Because essentially, this is a request response like format, right? Because we need to feed data in the model and get the output, and there are certain tokens. Uh, we built Linux with like POSIX and like GNU utilities, right? Like,
Yeah.
can we agree somehow on the standardized chat templates?
Mm.
Are there some efforts going that way, or um, why do you think it's so broken and separated as an ecosystem?
Yeah, that's a good question. So we did help fix some issues, and we helped, like, we noticed some quirks. So like, for example, the Gemma series of models from Google, Mistral, even OpenAI's GPTOSS, DeepSeek's models, all of these models. Like, it's not just one lab, it's like all of them have some issues. I think it's so we actually thought about this as well. Like, we thought at the very beginning, like, oh, okay, this is like an isolated problem, it's gonna be like a one-off.
Yeah.
But in actuality, it's actually getting worse. So actually, the more models we get, the more problems we see. Um, and I think the biggest issue is these large lab teams. They're like very. It's not like one person handling all of training, one person handling all of production. They're like disparate teams. So the teams are not really communicating with each other. So for example, the production team is not the same as the pre-training team, right? And the pre-training team is not the same as the post-training team. They're all like different teams. And so I think that's probably the problem. So there's like some communication loss between the team's communication process. I wouldn't really it's not really their fault. I would just attribute this to be like, the AI scene is moving very, very quickly. They don't really have time to like check every single small little issue. But I think that's probably why, they'll work with, for example, they will give us heads up. Oh, we're going to release the models next week or something. And then they'll give us like, oh, if there are problems, please tell us if there are like small little problems. So I think like I wouldn't really say it's their fault. I would more say it's like they're under a lot of stress to like release the models as fast as possible. They will do like a 90% check, the 90% good, but sometimes, the 10% is quite serious. Like they miss some, they miss like a BOS token, or they do the wrong EOS token or something. I think in terms of standardization, I think the most popular format is the OpenAI ChatML format. That's the most popular one. Some some large labs have kind of like used that. Like for example, Quen, they kind of use the ChatML format. Mistral has their own format. Google has their own format. So I think all of these large labs, they have their own format. I think my view is like they don't want to use one format, because if you use one format, then they can't distribute their models or something. So my view is like its standardization is going to be very hard.
Okay.
Yeah.
Well, that is good news. You'll have this job security for January come. The year 2200, fixing chat templates in uh, a new model released just recently. Right. Oh, okay. So this is very, very interesting because like on the application development side, right? There is a lot of standardization. There is a lot of reliance on open source core components, and so this is a very, very interesting glimpse into the ecosystem. So thank you for that. Can you talk a little bit about the local models and maybe
Yeah.
fine tunings and stuff like this? So as you said, the ecosystem moves at the like incredibly fast pace, right? To me, it like always reminds this, this GIF of from a very old movie where a guy sits in front of the train and fixes the train tracks as the train goes, right? So this is what I think of when I think of AI ecosystem. There are literally like millions of like hundreds and thousands of people at the bleeding edge and fixing issues at the same time as they're like introducing new issues and discovering, like it's just the moving trade and it cannot stop right now. So if we talk about smaller, maybe open source models, or maybe just smaller models that people can relatively easily run on consumer hardware, like maybe it needs to be like a maxed out MacBook or like a decent local NVIDIA card, but well, capable for normal people, right? Like you don't need day search for those. Do you still see a lot of capability improvements? Because we are now in what, like this is the fourth year of AI, current AI cycle, right? And then local models nowadays, according to benchmarks, are approximately what sort of state-of-the-art cloud models were maybe 1.5 years ago,
Yeah.
right? That, not to quote this, but they're very, very capable. And there is leaps and bounds what progress has been doing for local models recently, even this year alone. Do you think the space continues, or do you see sort of us reaching the kind of sort of the limits of capabilities, what we can do with this small size? What's your take on that?
Yeah, that's a good question. Okay. There is actually many components to that question. I think the first one is, I think in terms of capabilities, you're correct. Local models generally are very capable. And they're approaching, I would say like, yeah, very similar or nearly approaching like the frontier model labs, like GPT-5 or, and Claude 4.5. Like, they're very, very, very close, or they even beat it. I think like just the 6th of November. It's not, yeah, I was gonna say today, but 6th of November, they did release like Kimi K2's thinking model. And so like many people are saying how like, this is like, it literally like defeats many closed source labs models. So I think the capabilities of local models are being very like, they're very, very good. I think now the question is, will this continue improving? It's a hard question to ask because it depends on what capabilities we are measuring. I think like most benchmarks are kind of like saturated. There are like some benchmarks left which are like not really saturated. But I think like over time, every single time there's going to be like some sort of new benchmark. Like, every single year, every single like 2 months, someone will test these models on like some new benchmark. And then they'll get like, 0% accuracy or like 10% accuracy. So I think like once these AI models keep, getting better and better and better and better in like every single benchmark, then I guess that's how large labs define as AGI, right? Like until all tasks get automated, until all benchmarks, like every single benchmark possible gets like
Yeah.
80% accuracy. That's how we get to AGI. But I think in terms of local models specifically, there's always like a time lag between large labs and local labs. Local models. The time lag is generally around 6 months. But it is getting shorter and shorter and shorter and shorter. So like over time, the lag is going to be like 3 months. So I think, if the large model labs release like, GPT-7 or something, then you just have to wait 3 months later, and then you'll get like an open source model, which is like the similar performance.
Yeah.
So I think like the local models, they have come a long way. And they are very, very good. The only point I think is missing from local models is the tooling around it. I think that's the only problem. For example, if you use like, ChatGPT, GPT-5 Pro, they can do code execution inside the actual chain of thought. It can do web search. It can do the editing files for codecs. So that is probably what's missing in the open source world. Some sort of like open source model with all the tooling. And so if someone, if some startup or some open source project does something like this, that could be very interesting. So I think that's the only missing component for open source. Yeah.
Yeah, that is awesome. So uh, when you say open source models, right, you also currently are talking about the state of the art open source models. So the same Kimi K2 thinking is, do you know by heart like how big it is? Like it's
I think it's 1 trillion something, 1 trillion something. Yes.
Yeah, so it's an open source model, but I personally wouldn't call it a local model because
Okay, it's not a local model.
like
Yes.
it's impossible for with any like confidence to call it that you can run it locally. So you need a data center for that. You need like racks of GPUs for this. Even if you quantize that to something ridiculous like 2-3 bits, then it'd probably be a little bit off from the capabilities of like consumer hardware as of 2025. So when we talk about like maybe smaller local models,
Yes.
right? I would define that as a class maybe well,
Maybe
roughly
less than
say like
100.
yeah, less than 100, that like a 100 billion parameters would fit on a one GPU, right?
Yeah.
For actual practical local models, I would say that it's less than 30 billion or like
Yeah. Less than
about
30,
like
yeah.
30 billion, right? So because that's what people can run locally on their laptops
Yes.
or on the like a workstation machine next to it, right? So they don't actually need like a dedicated GPU access for this.
Yeah.
Do you think those are still rapidly progressing, like a small models? We can call them
Yeah.
small large language models. Do you think they're still progressing as well, or do you feel like their constrained size will be a much bigger bottleneck, and we're gonna see the difference between state of the art top shelf models and small models just going wide apart?
Yeah. That's a great question. I think like large labs, when they train models, it actually is very interesting. Like for example, when they released Gemma, for example, the biggest ones had the most tokens, and then the smallest ones had the least tokens trained. But according to like the scaling laws, the number of tokens trained times the parameters is around constant. So for example, if you make the model bigger and bigger and bigger, um, if you make the model bigger and bigger and bigger, you don't actually need to get more data. You can actually have less data, and you will perform the same as if you had a smaller model and trained it on for more data. So I think like if you want very, very small models, we have to train it for much longer on more data, and then you will get the same performance. For example, like, if you get like Llama 3 8 billion, I think it was like 15 trillion tokens, I can't remember, but 15 trillion tokens. We want to increase this to like 150 trillion tokens. and then the performance of Llama 3 8 billion will be the same performance as like 70 billion, for example. Something
Right.
along the lines of that. So I think like there is a way to make local models, the smaller ones, even smarter. You just need to train them for much longer.
Right.
And then there's the problem of like, how do we get all the data? Where are we going to get 100 trillion extra tokens? So
Yep.
that's
Yep.
the next question. But I think it is doable. It's just very expensive to do for the large labs for now. I think there's one way, for example, to like synthetic data generation or like doing reinforcement learning. You could like create data out of thin air. You could do that. And then I think the next question is, as the models, if you train the models for too, if you train the small models for too long, then as you said, like the capabilities might plateau. Because there's not much space you can move around anymore. If you want to like add knowledge to the model. And so you might have to like go to the next size, like 8 billion, then you have to go to like 14 billion. I think there's like no option. There's no more option for you to like keep training the model more and more and more. So there is like there is mathematical limits as well. Yeah.
Right. Well, yeah, I sort of, that is intuitively, I think, understandable that there are limits to that. So here's the thing. I think the smaller models are extremely convenient for various tasks. And this is a personal sort of way of thinking. So maybe you can tell me if this is gonna make sense or is this complete garbage. So you can use AI currently in two different ways, and one of them is to replace people.
Mm.
In a sense, what we want to build AGI, and then you'll have your AI assistant that is extremely capable, and you just throw whatever tasks or benchmark at them, right? And this is how we started with this. And you remember a couple of years ago, right? Everyone was doing, oh, now support agents are AI, and now once in a while you're like, oh, AI is going to replace developers,
Yeah.
and then or this AI can do the travel planning for you, so you don't need travel agency. So you're replacing the whole function of a person helping you, and for that, of course, you need the most capable models and the best performance, because it's also very hard to assess, right?
Mm.
Like you cannot say where the limit is. Uh, but also you can use AI for replacing software, and this is where you replace components in your system that have limited scope and limited function. For example,
Mm.
the normal from normal like machine learning, as there is maybe a credit card fraud detection.
Mm.
It's a very scoped problem, and you can maybe use a smaller model, more predictable model. And more importantly, to do that, your model doesn't need to know about the world. It doesn't need to know like different types of fishes or the World War II like events. It
Yeah.
just really needs to have basic knowledge about maybe some geography, maybe some what is a bank, what is money, and then sort of understand transactions and some regularities there. So I think this is where the local models can be super useful. And uh, do you think this is a kind of sort of a sensible way of thinking where the models can be applied?
Yeah. I think so. For the 2 points, the first one is like, I think I actually agree with you. Local models are very useful for specific use cases. Like, for example, it's not like, if you want, you don't need a 1 trillion parameter model to like, to like identify if this is like a good sentiment or a bad sentiment, like a news article. Like, you don't need a 1 trillion parameters. It's not necessary. So you can get rid of like, 999, billion of them. You can get rid of them. And so yes, I actually agree. Small models are very useful. And also it's much more energy savings, right? You can save energy. It's much faster for inference. It's much more, as you said, it's more predictable. You don't have to like, you're not sure what the large model actually said. And so like, I think for very industry specific use cases, the local small models can be very powerful for it. And so actually, that's actually what I see. Like, that's kind of the belief of Unsloth as well. Like, in the future, we will be having like small models very capable at specific tasks, and they will be deployed everywhere. On the first point, I think this is where there's like two different views. The first view is large labs. This is a large labs view. Their view is AGI will replace everyone. Everyone will be automated. There'll be no engineers. There'll be no artists. Everyone is going to be removed, right? That is what that is what they think. I think our view is AI recently it's very good for helping you design the inputs to like some sort of like final project. For example, if you're trying to like you can use, for example, like Gemini's image editing things, call Nano Banana to like create like a new image. Yes, you can call those to generate images, but you can't make like a final product out of it. And so someone needs to like synthesize all these tools and all these inputs to make the final product. So I think like, software engineers, like, people are like worried, is AI going to automate all of software engineering? That's unlikely. I think like software engineering is like not just software engineering, right? It's like planning, what project you want to take on. There's like many, many conditions of engineering, software engineering. It's not just the engineering part. And so I think like AI is very useful to help you design the inputs to like the final project, but it won't automate. It's very hard for it to like automate all of the entire role. But maybe, maybe in the future, maybe if AGI comes, it's possible. But for now, it's unlikely. Yeah.
Yeah, I agree. I think this week I saw that one of the frontier labs that create models that a lot of people depend on, they're also hiring some content writers
Oh, there you go.
for a very competitive package. Sorry. And if they cannot generate that content with their state of the art AI, that means that there's hope for humans to be competitive a while longer. So yeah, I agree. Like replacing people will not happen anytime soon, at least. But my comment was more about like thinking in general, right? You need the state of the art thing, and you throw whatever
Yes.
tasks at it, and you use it as a like hammer solution for anything you have, from I don't know, solving math equations to generating marketing strategies. So for small models, right, because they lack in this general uh, intelligence and world knowledge, because you kind of just cram all that information. Uh, you probably need to make them really capable at certain tasks. You need fine tuning. And so far, at least in my experience, when I say fine tuning, application developers sort of a little bit give up, and then they're like, okay, this is something for AI engineers, for machine learning experts. This is hard. It's impossible to do. Uh, I believe that we would get massively more successful if application developers will not fear this as a just general phenomenon. Do you think there is any specific machine learning expertise necessary for fine tuning small models? And maybe we can talk more about um, what's the general flow. Imagine you are an application engineer and you're like, oh, I need this model to be capable at task X, right? How do you assess? How do you assess like what size of the model is the minimum that you have, like where you can get results, right? What hardware do you need, and sort of how do you approach like data generation? Like how many samples do you need for certain things in general? Like, how is fine tuning working?
Yeah, that's a great question. So I think like you're correct. Like, many people are like kind of afraid of the term, like, fine tuning. It can be very hard to get around, like, what is the first step you need to do? I think the first question, as you said, like, it's the most important part of any single project, fine tuning or like, something else. There needs to be data. So like, I think the first step is like, if you want to design like an application, like you want to like, release some sort of application, do that first. And then afterwards, if you want to improve it, you know, please collect data, like, is someone clicking on this link, or like, is someone, utilizing this product well? What is the customer churn? Like, you need to have the data and save it somewhere. And then using this data, you can then make better decisions. Like, you can fine tune the model to do something. There's actually many use cases for fine tuning. For example, Cursor's tab model, for example, is a fine tuned model. Many legal organizations like Harvey, they use fine tuning to make legal decisions. I think Vercel's V0, so like to design like new applications, that's also a specific fine tuned model. I think was it? I think it was Stripe. Stripe also had a fine tuned model to detect fraud. So there's like many use cases of fine tuning. Or another good example, like Claude, like 4.5 Sonnet is a fine tune from the base model, right? So like ChatGPT is a fine tune of GPT base. So there's fine tuning is like it has many use cases, but I think as you said, like it can get a very like it is very daunting to start off. That's also like why we have like notebooks. We showcase how to do fine tuning step by step on our docs. And we also have like a Docker container where you can like just download Unsloth. You can open up. I think there's like we have like 100 notebooks for you to like search through. And you can click on like a notebook and click on it and read how you can do fine tuning and stuff. So we try our best to make the process as easy as possible for people to do. Yeah.
Right. So uh, the practical considerations of that, right?
Yeah.
So say I have a task, and say my task will be something simple, something like not simple, like what people have some intuition about. Do you know poker?
Yeah. Mostly, I don't actually play
Well,
it, but
you
okay.
don't have to play, right? But you understand that there are like cards and there's so, like imagine I want to train a model to give me correct answers for like a
X
given
card.
state. So like your cards and the cards on the table,
Yes.
right? And I want the model to tell me one of the three things, which is, well, call or raise or fold, right?
Yeah.
So I think this is a very constrained task because the inputs are constrained and outputs are constrained. So I
Yes.
probably can do with a very small model because I don't need to process like a lot of information.
Yeah.
So what would be like, how do I pick what base model is
Yeah.
capable? Can I go with, say, Gemma to 70 million, or do I need like a billion parameter model? Like, what would be your sort of approach to estimating the model size requirements?
Okay, firstly, that sounds like reinforcement learning. So actually, the correct methodology to do for that situation is reinforcement learning. And then the model, to be honest, any model can work. Small ones, big ones. So the trick is the smaller your model, the longer you will have to wait to get the correct, like a good result. That's the only
Okay.
difference. If you have like a larger model, you just need to wait like much shorter. So I think both small models and big models are fine. So to be honest, when I tell people to like try out fine tuning or like reinforcement learning, you should use a small model. You should not be like trying to like fine tune DeepSeek R1, like some gigantic model. I mean, waste all the resources. Maybe it doesn't even work. So I think like it's the first step is to use a very small model, like for example, Gemma 270 million. Like use a very small model, and then in the case of poker, that will be reinforcement learning. So the trick is you need to write the environment. So you will like design like an environment. You can also call, you can call ChatGPT. You can call Kimi K2. You can call like a DeepSeek, like a local deployed model to make the game, like make the environment. And then you want the AI to actually play the game. And then over time, the AI, like the model, will just learn poker. And so that's actually very possible. That's actually what the large labs are doing for every single task. So imagine poker is like one task. The other task is like the 2048 game. The other one is like, every other game possible. And then that's how they want to reach AGI, like, doing these specific tasks.
Right.
Yeah. But yeah, to answer your question, you can use like a very small model. And you should do reinforcement learning. Yes.
Right. Well, maybe that's not the best choice of the example, because maybe I want to do fine tuning. So I'll have some information where I have the hands
Yeah.
and the decisions, right? So I'm not trying to teach the model to actually play poker. I'm trying
Oh,
to
okay.
make it predict the decision, right? So my
Yes.
training data would be, say, the description of the hand and the game state, and I would ask it to predict what the person did,
Yes.
right? So we are mimicking like a human player, if you will,
Yes.
not building the state of the art poker player. Okay, so I take a small model. Say like for example, well, 1 billion parameter for round numbers.
Yeah.
So what's my hardware requirements for a model? If I have a model 1 billion parameters, do I need to fine tune in the full precision? Uh,
Not
can I
necessary. Yeah.
Okay, so like this thing. So I have a 1 billion parameter model, and I have say like 40 gigabytes NVIDIA GPU, right? Or 24, this L4 very affordable very easily obtainable. 24 gig L4 NVIDIA GPU. Can I do that? Do I need more hardware? How do I think about this?
For 1 billion parameters, I think you only need 6 GB of. So you only need like a 3060, I think a 30 NVIDIA 3060 or a 2080,
Right.
an AMD cards, like very, very, you don't, I think even on a mobile, a mobile laptop like type GPU, it should work.
Right.
Because I think the trick is we reduce the memory usage so much that you don't need that much memory requirement. So I think a 1 billion model only needs like 6 GB or 4 GB. I think it's 4 GB
Right.
actually. 4 GB of VRAM to do fine
Right.
tuning. Yeah.
So with 24 I can do like up to
Oh,
6
you could do.
or maybe. Okay.
Yes, you could do
So in
very, very
general,
well.
what's the rule of thumb? If I can run the model on this hardware, can I fine tune it on this hardware, or do I need more
So,
hardware to fine tune?
so for fine tuning, you will need some extra memory for the gradients. So it's generally, if it fits on your local device for inference, you just need to minus like a few billion parameters away. So
Okay.
for example, for 24 GB cards, the biggest one is 32 billion. So the biggest one you can fine tune is 32 billion, like Quen, for example. That will be the biggest one you can fit. Yeah, I think for the newer cards like the 5090s with 32 GB, then you can do a bit bigger.
Okay.
Yeah.
Okay. But like, if I can run a model, I kick it a notch
Just for a
down,
little bit
and
less.
I can.
Yeah.
Okay. 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 That very engineering approach. I like that. No, it gives me a rule of thumb, and it gives me some sort of mental model for this. So thank you. This is super super effective. And then so given a task in mind, right? How much? I think this is also very daunting for application engineers to understand because we don't get any sort of gut feeling about
Mm.
data, right? So if I have a task, how much, and sorry, it's very vague, right? But how much data do I need, right? Do I need to like always like millions of samples to train on and fine tune on? Can I go with like maybe thousands? How constrained would you say the tasks need to be to get away with like maybe like a single digit thousands?
Yeah.
Like, because I think there is a lot of mental barriers there, because as soon as you start talking about, oh, you need like hundreds of thousand data samples,
Yeah. Then it
like
gets problematic. Yeah.
it's problematic, out of my hands, impossible, both time wise and just capability wise. But if I can believe that I can fine tune and get some results with maybe hundreds of samples, right,
Mm.
just to see, like, because you just need to see the improvements, and then you can pursue it further if you think this is interesting, right? So
Yeah.
what's the minimum there?
So that is a very interesting question. I think so this is an interesting question because if you do reinforcement learning, the number of samples is 0. You do not need any data for reinforcement learning. The only thing you need is you ask the model, like, what is your task? Like, what is your question you want to do? And then you will call the model to generate your data. And then that's the
Yeah,
trick of reinforcement learning. But in terms of like general fine tuning, if you have 10 samples, that's enough. Because the trick is you can use your 10 samples to generate more data. So it's called synthetic data generation. So if you don't have enough samples, it's fine. You'll just get more samples. If you have 100,000 samples, then that would be like continued pre-training, like something like much more bigger. So I think like in terms of, I think the biggest difference for fine tuning is the introduction of reinforcement learning. And this allows you to like, you don't even need any data anymore. You just need to ask, like, I'll give you an example. You want your computer to generate algorithms, like new algorithms to do like sorting faster or something like this. And then you can just call the model to generate sorting algorithms. And then it will reward the ones that are the best. And then it will keep generating better and better and better ones. So essentially, you just created like an automatic algorithm generator for sorting. And you don't need any data at all. I think that's so essentially what I'm trying to say is reinforcement learning is like a special case of fine tuning, and it's even more powerful than normal fine tuning. Yeah.
yeah. Well, I understand that. Thank you. So for reinforcement learning, just need sort of the game environment where the model can practice and become better, like sort of a dojo for the particular benchmark or particular task. Uh, but if we talk about really like fine tuning, like we do, like LoRa,
Yes. Yes.
right, or any other Pokemon sounding word from a machine learning ecosystem, like can I like, as an application engineer, right? I have a task at hand. Do you have any sort of gut feeling about how much data a particular complexity task would need,
Yeah.
right? Or is it like a completely just experimental data? Like,
That's a good question. I think it's so minimum we see around 10 rows is enough. So for example, if you want to make like a chatbot, like a support agent, you just need
like
10 conversations and it should generally work. Um and then if you don't see, so the goal is to make the loss decrease over time. So generally the loss starts at like 4 or 3. And your goal is to move this number to as close as 1 as possible. So if you don't see the loss decreasing, it generally means you need to collect more data. So
like
generally we see like around 10 samples is good enough. And then over time, if you have more and more data, then add it to your data set. Um, and so that's also called continuous fine tuning. So you don't just stop, the one fine tune. When you have more and more data, you will update the fine tune over time.
right,
So I think yeah, 10 rows is enough. Yeah.
right. So this is for sort of the text-based text-based fine-tuning where the model needs to exhibit the general intelligence of a certain level, and then it needs to work with text at a in a certain way. Like for example, a support agent needs to be polite and
Yeah.
maybe rooted in truth, right, and not make mistakes in the company name. Which, well, I like, so there's some requirements, right? Okay, so as a rule of thumb, like a few hundred samples, if you have that, people watching, you are perfectly capable of trying fine tuning and then seeing whether it gives you better results. And
Yes,
then
that's correct.
after you taste those better results, after you were like this close to victory, you will find the will and the energy to do more data. Right. Awesome. This is incredibly helpful. Maybe the last question. So there were very popular nowadays multimodal models, right? Models that can handle different inputs, audio, maybe images. Uh, do you see any, or do you know any particular differences between maybe working with those, optimizing them, fine tuning them, versus just the text only models? Or is it all kind of sort of in the same ballpark and it would be as easy as with text only?
Yes, we made so in Unsloth, we essentially allow you to fine tune text to speech, speech to text, multimodal vision models, and text models, and so they're all part of the Docker image. So like if you use our Docker image, it will have all of the notebooks for all of the different types. And we try our best to make the process very similar to text models. But yes, it is very different. So for vision models specifically, you will see the loss starting at like 7 or 8. And it's much higher than text models. And so like that is a very interesting phenomenon. We're still investigating why, why is vision models having like such a large loss? We're not sure about that. So that's like an open question. But I think that's the only interesting part. Other than image models, the resizing of images can be different and stuff like this. There's those types of constraints. But other than that, I think we do. So we have like a few notebooks of how to do like X-ray. Is this like a cancer or not a cancer in the X-ray? Doing OCR, character recognition. We have like many examples on the Docker image as well. Clicking on, if you open up like a Jupyter notebook for all of them, you will see some examples as well. But yes, we try to. The process should be reasonably good. Yeah.
Awesome. Well, thank you so much. That makes me hopeful that maybe my applications could not only handle text, but some audio or visual inputs as well. Uh, in general, thank you so much for taking time to be with us. That is sort of the extent of where I thought this conversation would go, and you've been incredibly helpful with sharing a point of view and expertise on the subject. If you would tell something to the people watching, or maybe if you don't have an idea what to say, like how would people get started with trying Unsloth libraries? um
Yeah, like we have like a Docker guide, so you can you know, download our Docker image, run. I would suggest people to try the GPTOSS 2048 game. So you will essentially teach the model to play the 2048 game using reinforcement learning and fine tuning. So I think that's probably the best example to do. And then we have like lots of docs of like, how to do fine tuning, how to do reinforcement learning, how to actually, if there are like some Docker issues, how to debug it and stuff like this. But I think our Docker image has all the components necessary to do reinforcement learning, fine tuning, even inference. So we have like, it's all in the Docker image. So I would
Right.
definitely ask people to like try that out. And yeah, if anyone has any questions, we have a Discord. So definitely bug us. Yes, but thanks a lot for inviting me as well today. It was very, very fun.
Thank you a lot, Daniel, both for information and coming today, but also for the work on Unsloth. It's really like one of the pillars of the ecosystem and open source and the local models. So that was extremely, extremely good to have you here. Thank you everyone for watching. If you have any comments, leave them here, or please join the Unsloth Discord and ask your questions about fine-tuning, maybe packaging the local models, small models, open source models, and running models with better and faster inference and lower memory requirements. Until next time, cheers.